Hello, my name is Sajjad Rezvani from Shahid Beheshti University. I want to talk about reinforcement learning applications for electric vehicle in power system, which is a very modern application of intelligence, artificial intelligence in industrial applications. I want to talk about um, in very brief way, maybe about 5 to 7 minutes. So let's start the discussion. First of all, the whole thing is about renewable energy resources. As we know, renewable energy resources are very useful these days, and they are becoming more popular in our cities, in our industry, and so we should adopt our facilities to this renewable energy. And one of these facilities is electric vehicles or EVs, which are very actually important from different aspects. As you see, there are several companies like Tesla, Benz, and even China's company that they are trying to improve their cars and build new electric vehicles or hybrid vehicles, as they know it is the future of this industry. So another aspect in this topic is a power system, which actually provide electricity for these car. Let's see the vehicle to grid technology definition, which is important in this way. Vehicle to grid technologies means the technology that connects vehicles to power grids. So vehicles could be charged for human usage. So we should manage these charging for vehicles in power system. And absolutely, there are too many challenges in this way that we should face for actually provide better efficiency. This is a new issue that should be solved for power systems. So let's talk about limitations of model-based optimization method. In the older ways of modeling power grids, they used model-based optimization method. So they tried to model the whole power grid with some capacitors, resistors, or inductors, and they solved the whole problem to evaluate the system values and the system variables actually. So there are some challenges for these model-based optimization methods, which two most important of these challenges is dynamic and stochastic environments of power grids. As you have dynamic and stochastic environments, it's hard to efficiently model your system. So you need a more effective way, a more effective method to handle these troubles which happen in the power systems. So as you see, there is a comparison between model-based system and not non-model, actually model-free. It's better to say model-free system like RL, which is reinforcement learning method that actually uses model-free system to control the whole system. So as you see, in model-based system, you have models, parameter, uncertainties, and it's hard and time consuming for re-optimizing these parameter of model. But in the model free system, you have an state, you have an agent, reward and action. So as the system changes through the time, you can learn new things about system. Actually, the agent learns new things about the system based on the reward that it gives, that it gets. Sorry. It could do some new actions, take some new action to better control the system and get the better states of the system. It's time to introducing the reinforcement learning or RL. RL is one of the important and popular actually methods in the artificial intelligence, which in this way you try to create an agent, an environment, and put the agent in the environment and make your agent to learn new things, make new things by try and error, um, and it's like baby which try to walk, and by try and error and do some wrong movement which leads him or her to fall. After a while he or she learns to walk. It's the best example of reinforcement learning agents. In this way you can capture the uncertainties, as the system is very flexible to changes and uncertainties in the system. Um, and As I mentioned in this slide, adapting to state conditions in real time. It's the merits of these way of controlling system. So in this slide, you can actually see the reinforcement learning methods uh, deeply. As you see, there is a value-based and policy-based methods in reinforcement learning. The Actually the left equation, it's the Q equation, which is a value function of every state and actions, and in the right side we have a V function, which is the state value function, which just evaluate the state quality, or the state value. So in every state, the agent gets a reward from environment and learns about environment, and by new actually system sorry by new algorithm or new parameter, it's better to say parameter. It's I mean agent try to take an action, new action, which is better than older actions. So application of RL in EV dispatch problem. It has several application. For example, it could solve the EV dispatch problems, and as I mentioned, it could handle the instabilities and actually uncertainties in the system better than older methods. But on the other hand, it has some key challenges, like complex state space. To explain this challenge, in RL system, as the state spaces, the number of state spaces increase, the problem, the solving the system, become harder and harder, and it could be very time consuming, and it could increase the cost of the solving the model too much. And also dynamic environments are a huge actually challenge in the RL problems, um, as the other different methods in system control. And another point is exploration versus exploitation trade-off, which is a very important trade-off in the RL methods. You should actually handle these trade-off by assigning some parameters in the model. So it's very important to evaluate these parameter in a best way, so you have enough exploration and enough exploitation, and it could diverge the learning process if you choose a wrong parameter for this trade-off. And another point is computational complexity, as I mentioned earlier, that it could be very time-consuming, and it could be high. It could have high cost, computational cost. So these are the RL method challenges. Um, and in this slide, I mentioned exactly some of the RL algorithm applications, a specific RL algorithm in a specific application of the power system, to dive deeply in RL algorithm. But I think, there is no time. I should explain faster. You can um, return to the slides later and see the content. So also in this slide, I compared some of the RL methods, which are very famous, like Q algorithm, Q learning, DQN, which is a deep Q network, or newer and modern methods of RL, like PPO or DTPG. So for conclusion, we could say the integration of reinforcement learning into power system for EVs application is very much, and it could be very helpful and useful to increase efficiency in these systems. And by addressing challenges and leveraging opportunities, we can pave the way for sustainable and efficient energy future. So there are some future research directions in this field, like data quality and availability, because one of the important challenge in all of the artificial intelligence methods or machine learning methods, it's about data. So by having more qualified or data with more quality, you can have a better algorithm with higher accuracy. So it could be one of the research directions. Another point is environment setup. So it means we could have some environment or simulations to test these RL algorithm. It's very important. One of the most important libraries in this field is Gymnasium, which have lots of different environment for lots of different actually problems. And one of the most topics in the engineering is safety and robustness. When your system is important, when your system have a great role in a human life, like power system, it's very important to have high safetyness or high, and robustness in your system. And and as all engineering problems have these points, real world deployment is a very big point when you should put out the simulation and try to deploy your models, your algorithm, your method in the real world. And these are my resources. There are some very useful review papers about this topic. And thank you very much. Um, you can email me if you have any question.